Thank you everyone for joining us on day 2 of Build with Mapbox 2025. My name is Chris Wong, Head of Developer Relations here at Mapbox. This session is Build an Agent with Mapbox MCP. Before we get started, I have a few logistical notes. Valentin, if we could hit the next slide. All of the build sessions are recorded and will be available to view after the event. We'll be inviting live questions for our guests. To participate, please submit questions through the Zoom Q&A feature, not just in the chat. So there's a little Q&A button at the bottom. Captions are available in multiple languages. To enable them, please use the captions button at the bottom of your screen. You can discover all of the build sessions available today throughout the week in our Zoom event lobby or on the web at mapbox.com/build. That's it for all the logistical notes from me. So I'm going to welcome our presenters to the virtual stage. Please welcome Mofei Zhu, software engineer at Mapbox, and Valentin Salmanovikas, machine learning engineer. Take it away.
It's nice to be here. Thank you so much, Chris. So today we'll be trying to build our own agent, and for the agenda is Mofei is going to introduce Mapbox MCP. That's going to be an important prerequisite for us to actually build an agent. Once we have that, I will actually do a demo of how you could use Mapbox MCP and how you could build an agent. And there will be multiple iterations of this demo, and by the end of the session, we'll have something exciting. Mofei, over to you.
Thanks, Valentin. I will start with a very brief introduction about our MCP and then head back to Valentin for the detailed show and tell. At Mapbox, we build MCP tools based on our most popular APIs and use cases. This lets your favorite agent or MCP client like CodeX, Cloud Code, Cursor, etc. can connect directly to Mapbox APIs in a natural, conversational way. Here is our GitHub repo link. You can always find the detailed information about it. Next slide, please. Here, I'd like to highlight a few use cases that we find valuable. For example, this is a location discover and search. This is a very common use case, especially when you go to somewhere new to you. For example, you can ask your agent to use our category search tools to find the coffee shop, cinemas, or any other thing like supermarket. It's very convenient, and the agent can get a precise result from our tool. Next slide, please. And we can also use our tools to do navigation planning. For example, with direction tools, you can ask the agent to get a route from one place to another place. And of course, our direction tools can accept different parameters. You can even ask the agent to send a different profile, like by walking or by car. For example, if you want to go to some places, you don't know whether you should go there by foot or by car, the agent can call our direction tools and get a suggestion for you. Next, please. This is my favorite use case. It's very convenient and can save us lots of time. For example, if you're in San Francisco and you know you will pick up one hotel from 3 hotels, and then you know the other day you will go to maybe 2 places, and you want to know which hotel is best choice. With our POI search tools, the agent can get the precise location coordinates of each hotels and the target places. And after the agent gets the precise locations, it can use our metric to figure out how many travel time from each hotel to all the places. And the agent could summarize a result, so you can make decision based on this result. This tool can save us lots of time. I super like this tool. Next, please. Besides what I explained above, we have more tools. I will not going to go through each one. Feel free to check our GitHub repo, and you will find the detailed information about this. And one more thing, we do have another MCP. This MCP was developed for our developers. So with this MCP, you can manage your styles. You can check our documentation. You can even manage the Mapbox token with easy way. I will not gonna to give a detailed introduction about this one. My colleagues will have a separate session to discuss about this. If you are interested with this, please join. Of course, both standard MCP and the delicate MCP are maintained by Mapbox. So which means we will have regular updates, bug fix, and security updates. Feel free to use it. And of course, if you have any questions or any tools you want to use but not exist in the MCP, you can feel free to cut a ticket in our GitHub issue. Yeah, that's all. And let's move back to Valentin to talk more about building your own agent.
Cool. Thank you so much, Mofe. I would like to now start building. Before we actually go ahead, a quick note is that we will use Crew AI framework to define a crew of agents that will work collaboratively to solve a shared goal. The role of the system that we're building will be to act as a helpful assistant that can find routes, plan small trips, find places, answer questions about locations. And this will be powered by Mapbox MCP as a set of tools that the agent will be leveraging. So now let's actually go to the demo. And for the demo, I'm starting with a blank VS Code project. It has few files related to package management and environmental variables. I want to show you environment variable file that is an example of what you'll need to have if you want to reproduce this. There is a Mapbox access token that you will need to provide. This is what's going to be used by Mapbox MCP. There's OpenAI token that you will need to use if you are using OpenAI. You could use other providers as well, and the Crew AI framework is provider agnostic. I'm using OpenAI for this demo, and specifically I will be using GPT 4.1 model. So the first thing that we'll need to do is to actually create a structure for our project, and QAI has a command that you can run that will do this for you. It does create few files that we will not need, so actually I've done this beforehand and I've removed things we will not be using. So we have a few files to start here. One of them is directory with configs. I will go into that in a second, but the other one is a main.py file, which is going to be an entry point. This entry point has just the main function, and the main function takes a prompt from command line. That prompt is passed into a run function, and run function creates an instance of a crew, and it kicks off the process with the input. The input is a dictionary, and that dictionary has a few keys. Those keys are used as a templates for our agents and tasks. If I go into agents file, it's a YAML file that defines right now only one agent. And it's a very simple agent. It's a helpful agent. It has a role of being helpful, and it has a goal. And the goal is to try to help a user who provides a certain prompt. That prompt goes into a template, and all of these templates, they are provided from our entry point main function. As far as the agents go, they also need tasks. That's how Crew AI framework works. And for tasks, we have a separate file, and this file defines a template of tasks. There's only one task at the moment, and it's defined as a task where the agent needs to use tools and its own general knowledge to answer the prompt. The prompt is also provided here as a template variable. We are almost ready to run this very basic crew of only one agent. There's a crew file that specifies how to create an instance. And this crew file, it has an agent that's being created, and it has a task that's being created. To create an agent and a task, it just refers to our template files that we looked at a second ago. These tasks and agents, they are part of a crew-based class, which is also is provided to us by Crew AI. If you run a command that creates a demo project for you, and it's actually all that we need to run this already. We have not plugged in our MCP just yet, but I do want to show that we can run this. And in fact, if we use a run command, we'll be asked for a prompt. For our prompt, we could ask something like, where is Greenwich Footpath Tunnel? And the agent should be able to kick off a task for a help task. And that task will provide us an output. The output is based on the general knowledge of the LLM. It's not very interesting just yet. So the next iteration that we can do to this is actually plug in our MCP. So the agent becomes more factual and more capable with respect to location-based queries. So for us to do that, we need to import a few packages at the top, and we need to create MCP server parameters list. This is something that QAI expects to see in this base class for it to be able to connect to MCPs. It's a list, so if we have multiple MCPs, we could provide multiple of them. Right now, I'm using just our main Mapbox MCP in here. The only thing we need to do for us to be able to use this MCP as part of the agent is we need to specify that our helpful agent, it needs to have some tools, and those tools will come out of the MCP. The tools should automatically be discovered from an MCP, and in fact, this is good enough for us to rerun and ask the same prompt, and we should see what Morphe was showing earlier, where if we ask, where is Greenwich Footpath Tunnel? What will happen is the agent will use appropriate tool to find the tunnel that we are looking for, and it will respond in similar way as before, but this time it's based on the tool output other than the LLM general knowledge, so it's a little bit more robust. I want to do very quick recap, which is that so far we have one agent, and that one agent has one task. This already can be useful, but we still have plenty of time left, and I want to do a few more iterations that will make this a little bit more exciting. So let's do more. I have a vision for the next iteration where we don't want to stick with the terminal app. We perhaps want to use something more visual. And for that to happen, I want to use GeoJS map. So for this, I will need to create a page. I have a very simple page in here that creates GeoJS map. It's not very interesting just yet. I will not go through the entire file just in interest of time, but we have our very basic page. For us to display this page, we'll need to create a Flask app. For that, I have a separate script. This script has two endpoints for a Flask app. One endpoint that just shows just renders our homepage, and it's using our template file that I was showing a second ago for that. The other endpoint is to submit a prompt. So the page, it has a chat interface, and the chat interface allows you to submit messages. If you submit the message, you will get back a stream of responses. There's going to be one response at the very beginning, which is going to be just one sentence saying that we are analyzing your location query. The second response is going to be similar to what we've seen with the terminal output, where we take the message, we run that through the queue, we get the output, and that output will also be sent as the second message of the stream. The entire stream is just two messages. The very last thing I need before I could run this is to create an entry point for this app, which is just a run demo script. The script is very simple. We just import the app and we run it. That's pretty much it. So if I rerun this, it should be a little bit more interesting in that we will have a page and we will have a map. And we will be able to extend that in a later iteration. So if I open this page, this is how it looks. There's very simple chat interface. There's a map. We could ask, since we're in New York, let's do where is Times Square. It will work in the same way as before, where the agent runs its set of tasks, and then it responds, and that goes into chat box. It doesn't go on a map just yet, because map is completely isolated from the agent. So this is where I want to take it up a notch, and I want to make the agent interact with the map. So clearly, when we ask for locations, we want them to be displayed. So maybe let's try and do that. Let's make the agent capable of showing data on a map. So for that to happen, I want to introduce another agent. So right now we have only one agent, but let's improve that by adding one more agent. This agent will be tasked with producing GeoJSON output. So this agent has its own role, goal, and a story, and now we have two agents. For the new agent, we will need a new task. Each agent can have multiple tasks associated to them, but right now we don't have a task for this agent, so I'm creating a new one. This new task has a few lines of description. I'm not going to read the entire thing, but importantly, the task is for the agent to produce a structured response. That's what we expect as an output. And that response needs to contain a text and GeoJSON field in the response. This task is for our GeoJSON agent, and there's something that specifies that this task needs to be in context of a task that runs beforehand. So each agent is by default not able to see what all the other agents are seeing and doing. So here I'm just saying that this specific task, it needs to see an output of the task that runs prior to it. So now that we added an agent and a task, we need to update crew so that we create an instance of those. For this to happen is going to be similar to what we've seen before, where we had a helpful agent that's created from a config. So right now we have also a GeoJSON enrichment agent. It's also created from the config. One difference between the two is that GeoJSON agent does not have MCP tools. We could give it those. I don't think it needs them. I think it could use the output from the first agent to figure out how to produce GeoJSON. In the crew, we also need to create instances of tasks. So we have a help task that we've seen before, and now we have a new GeoJSON enrichment task. This task is different in that it's based on a different part of the config, but it also has an output JSON field, which says we want a structured output from this task. If we look how that is defined, it's defined as an object, that's a paradigmatic object, which has a schema that requires it to have a text field, and it can have a GeoJSON as well. That is optional. We're almost done, and we can almost run this second iteration. We just need to do one more change, which is to our app. So our app, right now, it gets the output from the crew as a string, and it just sends that out. So we want to change that. Since we have a structured output, we don't need to expect the output to be a string. We can expect that to be an object that has text and a GeoJSON, and we'll be sending those two out. I will not spend too much time on our template, but the template in essence expects that if the response has GeoJSON, then it needs to create a GLJS layer and put GeoJSON in there as a source for that layer. So I think we can run this now. If I go into terminal and I run this app again, what's going to happen is we have the same page. If I refresh it, we could ask again, let's ask for where is Greenwich toolpath panel. If I can type today. And so what's going to happen is we have a help task, same as before. It's using POI search to figure out how to respond to this task. And then there's GeoJSON enrichment task. This GeoJSON enrichment task runs afterwards, and it will produce a GeoJSON that goes into basically a map. So some of the output now goes into a map, some of the output goes into a text bubble. So we see 2 points that it found, which is a south entrance on the south bank, and there's a north entrance for the north bank. So let's do a very quick recap of what we have so far. We have 2 agents, they have 2 tasks, and we have a Flask app. The Flask app parses or passes the output from GeoJSON agent into front end, which has a template to render a page with a map. And part of the response from the agents is being put into a map as a layer. Part of the response is being put as a text into chat bubble. It's already quite useful, and we could play more with this, but I want to do a little bit more. So if we come back to VS Code, if we kill the app, and if we clear the terminal, I want to do one more iteration. And in this iteration, I want to take it up a notch even more. So I want to create an experience where if we ask the agent to show us something, it's not just putting data on a map via GeoJSON, but it's creating a little camera action. Basically, show us different angles of different places and maybe fly around and do a tour of places, and maybe even more. So for that, I will create one more agent. I call it camera choreographer agent, which basically has a goal of creating a sequence of camera movements, atmospheric effects, and stuff like that to make it a more interesting experience. For this agent, we will need to add a task, same as we've done for other agents. The task description is going to be slightly different. In this task, I'm asking the agent to produce a series of commands. Each command will be structured output, and commands, while looking at the description of a task, you can see the commands, they're expected to be like a dictionary, specifying what command type it is and what parameters it has. There's a command to fly somewhere, there's a command to set lights, set fog, set rain, etc. It's predetermined, so it's not completely like made up by the agent. The agent has some kind of schema that it should follow. For us to be able to run this, we'll also need to update crew. And if I look at crew.py, I have introduced a new agent into here. I give this agent MCP tools, similar to our helpful agent, because I find that for this agent, maybe it wants to pick different POIs, or maybe it wants to go further out from where the user is asking it to go. So maybe it can make use of those tools to create a more interesting scene. For this agent, we'll also need to define a task. I have that at the bottom. This task is also populated from the template, and it has an expected structured output that we need to produce. Looking at that structured output, it's similar to what we've seen before, in that there's a text, there's a GeoJSON, and there's a list of map commands. These map commands, they need to be interpreted by the front end, and how we do that, I will get to that in a second. But before front end can do that, we need to actually send that out. So for us to do that, because it's a structured output, it's just one line change, which is making sure we are sending out a text part of the response, a GeoJSON part of the response, and a map commands part of the response as well. For the front end, it needs to basically interpret those commands as a sequence of events. So it has basically a switch statement, and for every type of command, the switch statement tells it what parameters it needs to parse, and for those parameters, it will be able to execute some kind of function that should be based on GLJS interface. It's pretty verbose, but it's all quite simple, and it should be quite easy to reproduce. Later on, after this build session, I will also share this on GitHub, so you could try this for yourself. But in essence, when we get a response, we parse that response, and part of the output is being sent into all of these different functions that handle different parts of the response. If we, for example, receive a command to set a snow, then the switch statement just tells that GeoJet's map should change a config property to create snow. In fact, this is all that we need to do to make this next iteration. If I run this demo, what we should have is a map that is the same as before, except we now can ask it to do a bit more interesting things. So if I refresh the page, and we get the blank map, I could say, show me Boston Financial District and some banks around it, and let's fly around it in dawn lights. This is more complicated prompt, so it's going to take longer because naturally there's more work to do, and now we have more agents and more tasks. But it's going to be similar to what we've seen before. First, we have our helpful agent trying to figure out what it needs to do with this prompt. It's using different tools to find banks, and in some cases, it might use static map image tool. In this case, that failed because it returns an images that the agent is not able to interpret. But that's okay because it's an agent that's able to deal with cases like this, and it will use other tools to get where it wants to get. It will think about the problem. It will think if it's found enough information, it will pass that to GeoJSON enrichment task, which is running right now. After this task, there's going to be camera task, and this task might also use different tools. And this will take a second, but as it's doing that, what's happening is that it's trying to create that structured output that will contain a bit of text that goes into text box. It will have a bit of GeoJSON that will be a layer that will be shown on a map, and it should have a series of commands that the front end knows to execute with a certain delay, and the agent also specifies how much delay between each command. This takes a little bit of time. Maybe the agent is using tools and doing the exploration. I don't want to switch the screen so we don't miss the action, but it should happen any second now. So we get a bit of output. It goes into text box. The lights change. It seems to be dawn lights. We move to Boston Financial District. We zoom in. We have a few points that GeoJSON enrichment agent put on the map. And the camera is moving about on its own. It's based on the commands that the camera agent provided, and it's pretty cool. If you reflect on how much effort went in for us to create this use case, then you can probably agree with me that it's very exciting and it's very inspiring. And moreover, there's nothing like in our configs to specify where is Boston Financial District, where are the banks, or how to look for banks specifically. It discovers how to do that from the tool descriptions of the MCP. For GLGS, there's again nothing specific that it knows about GLGS, except that we gave it a few commands that we asked it to execute and interpret. This is might be a good transition into some challenges that we have. Of course, this setup is quite scrappy. So I'm refreshing the page, and let me look for something else. Let me ask for what's an ETA for driving from LGA to JFK, for example. In this case, I'm looking for the agents to perform their series of tasks, and this will produce an output that will contain a bit of GeoJSON as well that we've seen before, except it's going to be less precise than we probably want to have. And that's the issue I want to highlight. And I want to spend a few minutes describing how you could also attempt to fix that issue. So when we get our output in a second, what we will see is that the output contains a GeoJSON that doesn't exactly follow the road layout. And part of the problem there is because I will show this later on is I'm asking agents not to pass big objects between the tasks, between different agents around. I'm asking it to simplify geometries. So when it's using directions tool and it finds the route, it will try to simplify it rather than passing the object directly to other agents. And you can see it doesn't exactly follow the road network. And this is where I want to turn to the description of a task to show you that this is kind of the problem of how we ask the agent to behave. So in my help task, I have a part of expected output dedicated to description of how it should be passing the data between different agents. And for GeoJSON enrichment agent, the success of that task depends entirely on the output of the help task, which means that the help task needs to provide enough context for GeoJSON to be meaningful. And for the agents, it's really difficult to pass around GeoJSONs that have a lot of coordinates. And if you want to follow the road network very well, it's just a lot of tokens. So I'm asking the agent to simplify the route and only pass 10 or 20 points that it finds from that GeoJSON as a sample. I'm asking it to do a crude approximation by just taking random points. But it's really inefficient for the agents to, even at this point, try to read GeoJSON. So there's few ways we could handle this. One way is we could pass the GeoJSON as a file, and we could ask other agents not to read that file, but work with that file if they need to. And in this case, they may not even need to read that file entirely. They could just refer to that file and pass that somehow later on to our front end. One other way is maybe to use MCP resources. This is something we are actually thinking as a team to introduce as a change to MCP, such that for directions tool, for example, we do have a GeoJSON that the agent can get in the output, but that's an optional output. The agent needs to specify that it wants to get a GeoJSON in the output. If it doesn't want to receive that, it will not get that by default. We could perhaps put that in resource, but it depends on how our customers are using our MCPs and what kind of things you're building. So do get in touch and do let us know if you find any issues, if there's something you struggle with. Perhaps let me refresh and do one more example where we could ask for let's ask for give me a 30-minute driving isochron starting from Brooklyn Bridge. And this will allow me to highlight one other nuance of our current implementation, which is that it is quite slow. So obviously, as I type this in and as we wait for a response, there's few things that need to happen on the background. There is an interpretation of what is a Brooklyn Bridge. It's probably a place. So for that place, we need to get coordinates. How do we get the coordinates? We need to use geocoding tool to get that coordinate. And then what's an isochron? It's something else that we need to use a tool for. And all of this is a sequence of tool calls that the agents need to perform. And when they perform all of these tasks, they build out the context that they then pass around to other agents. And because we have multiple agents, by adding each of those agents, we actually increased latency end-to-end quite a lot, just because for each agent, we have more tasks and basically more things that need to happen in a sequential way. And the key word here is sequential. So with some tasks, you cannot really go around that. So some tasks you have to do in a certain specific order, and you cannot skip a step, or you cannot necessarily do things concurrently in parallel. However, with Creo AI, you can have a process that's nonlinear. You can have a hierarchical process where agents work asynchronously. There is one manager agent that is able to request other agents to perform certain tasks. It could even tell them exactly what they need to do, or it could just tell them that they need to do their part of expected workflow, and they go and do that. And in this case, we have a camera agent, and we have a GeoJSON agent that perhaps could do some work in parallel. For one, the camera agent has its own tools, so it could go and figure out all the camera angles and all the places it wants to fly to, separate from GeoJSON agent. And GeoJSON agent, it looks on the into the output of our helpful agent. So again, it does not depend on the camera agent. So those could work in parallel. So for that to happen, I will not have time to show that. But in essence, it's really quite a minor change. So at the bottom of crew.py file, we have a way to specify what kind of process we are running. Right now, we use the default thing, which is a sequential process, but you could use hierarchical process. And that would basically help you to reduce the latency as well. And as you work on these things, you will probably encounter issues, and you will find certain things that it's maybe difficult to solve, or you don't know exactly how some Mapbox API or functionality could be used to make that happen. And that's where you really need to get in touch and tell us what you're building, what problems you're facing, and we'll help you get there, or at least we will help you to understand why it's not the way you would expect it to be. But with that, I want to do a quick recap, which is we now have 3 tasks. Those tasks have separate agents that executes them, and we have a Flask app. The app is getting a structured output from the crew, and the output goes into chat bubble, and it also goes into GLGS map. For camera action, we have a sequence of commands where we just have a switch statement and we loop through every command on the front end, and we execute that command as the crew provided. For every command, crew also provides a little bit of delay. So if we ask for some quick sequence of events, it should produce an output that's a little bit faster. So with that, perhaps we could move on to Q&A.
Excellent. Thank you so much, Valentin. That was an amazing demo. Couple questions. I'll start with the simplest one from Ellie, which is, will we be able to pull this code after the talk? Are you going to publish this anywhere where people could grab it so they can have kind of a working thing to start with?
Yes, the answer is yes. I will put it out into public. Probably not today. I will see how I can do that with my schedule, but it will be out there soon. Let's put it that way.
Would that be in a Mapbox GitHub repo or your personal GitHub?
Mapbox.
Mapbox. Okay, so stay tuned for that. Hopefully we can make that easy to find. Okay, next question. Is there an MCP tool that doesn't seem to work in our if there is an MCP tool that doesn't seem to work in our application, like static images, is there a way to stop the agent from being able to use that tool? Is there a preferred, and second question is there a preferred model that has the most improved results when you're using the Mapbox MCP server? They said they're using Azure OpenAI service LLMs, but curious what your experience has been.
Yeah, so depending on the framework, you should be able to specify which tools you want to use. So with Crew AI, what I'm doing here is I have a function that's a built-in function in Crew. I did not have to write this function, but this function gets all the tools from all the MCPs that it can get from parameters. If I don't want to use one specific parameter, I could change the list of get MCP tools results such that I only get those tools that I want. That's one way. The other way is more hacky, where you can actually change the MCP server, rebuild it locally, and run it with fewer tools as part of the server as a whole. And if something doesn't work, of course, also do get in touch. There's a few ways you can do that, and one of them is you could create issues on GitHub repository for MCP. You could also use support pages and the documentation on mapbox.com.
And to the question about LLMs, did you have different experiences with different ones so
Yeah,
far?
so experiences are very different with different ones. It's not that some work and some don't work. It's that they work in different ways. I found that some, like Claude, they want to do a lot of work. So they would use more tools and they would do deeper dives. Some agents, they require that to be part of a system prompt where you tell them that, you need to really dive deep and you need to work on a task until you're really confident that you solved it. So that's one difference. The other difference is, of course, how smooth the process is. Sometimes if the tool is complex, it might not always use the parameters in the best way. It might not use some parameters at all, or it might make mistakes. So the bigger models, of course, are more intelligent and more capable. But it's hard to say which one is really better. It all depends on the use case. Internally at Mapbox, we try to make benchmark and we try to basically rerun through that benchmark different prompts, see how different agents perform, and decide based on that how we want to keep going. We could, of course, fine tune the models as well, but I wanted to show something today where we don't need to do any of that, where we could just prototype using existing open AI models without really spending a lot of investment trying to train something.
Awesome. And I guess this has been out for, I don't know, a month maybe, or at least really out in the world for people to use. What are you seeing people build with it? What's the most interesting feedback or interesting use case you've seen from anyone trying to implement with it?
I think and maybe Mofi could pitch in on this as well. I think the most interesting use cases are the ones where you need the agent to act sort of like a glue to stitch together a lot of functionality. So, for example, you might be able to create a script that can show you something on the map, or when you click a button, do something else, or when you click a button, something moves or something changes about the style. But you cannot do it in a robust way because you have to anticipate what's going to be the question, what the user is going to intend to do. And agents allow you to make that more smooth. I've seen example that was built internally where someone was changing the styles of the map, and it could be very useful if you want a prototype. So maybe you want to create a style that will match certain theme or topic, and you don't want to spend time trying to understand how to manipulate styles or what properties do what exactly. So agents are good for that. I also have seen example where someone was building a map where you could ask it to do a little bit of analysis. You cannot, do a very sophisticated analysis with the set of tools we have right now, but that use case was using other MCPs to support the agent. It was doing like web search and using some results to plot that on the map, and basically working with different tools like directions tool to figure out how you would route between certain points. I think I'm not sure how many of those use cases are in production because obviously there's a lot of challenging to scaling this. There's challenge of guidelines. We have not even touched on that today, but you need to make sure the agents always say the right thing. There's a challenge of how you make this cost efficient. For that, you might try to front load a lot of tokens and a lot of context into the agents such that you benefit from cached token inputs. You might also have use cases where it makes sense for you to train the agent. If you fine tune the agent, of course, it becomes more capable and it knows how to use these tools a little bit better. It makes fewer mistakes and that makes it more cost efficient.
Yeah,
Great. Oh, go ahead.
sorry, I can also share a use case which shocked me. But this is not related to the standard MCP. It's related to the dev kit MCP. So previously, when you're trying to create a style, you have to go to our studio and to maybe spend several hours to create a style. But with dev kit, you can just create a style with one prompt, with 1 minute. So it's really amazing and it's shocked me.
Excellent. Okay, so for one last question, how many Mapbox services are currently available with this MCP server, and what are the plans to expand it?
So right now we are only support a list of tools, so you can check from our website or GitHub repo. Our goal is not to support all the tools. we are trying to focus on the most common use case. Of course, if anyone have any requests to add some new tools, feel free to cut a ticket in our GitHub repo.
All right. Well, thank you so much, Mofe and Valentine, for this awesome tour of the MCP server and a great demo. Thank you all for joining, and hope you enjoy the rest of Build with Mapbox. Thank you for attending. Take care.
Thank you. Bye-bye.